Hey guys, welcome back to gases. In part 5 of this unit, we're going to be talking about stoichiometry, specifically gases relating to stoichiometry. Let's get started. First of all, stoichiometry, if you remember, is calculating relative quantities of reactants and/or products using the balanced equation. Essentially, it's something that's going to look at the mole-to-mole ratio of two or more substances in a balanced equation. If I have 5 grams of hydrogen, how many grams of water will be produced? If I need 22 liters of water, how many liters of oxygen will be produced? So we're just looking at the ratio when a balanced equation. Let's get started with an example problem. So we have number 18 in your notes. H2 plus Cl2 makes 2HCl. How many liters of HCl, question mark liter under the HCl, will be produced when 5 liters of hydrogen, 5 liters under the hydrogen, react with excess chlorine at STP. Excess means that there is more than plenty of the chlorine, so we don't really have to worry about how much chlorine there's there, just plenty or excess, so I X it out. So because stoichiometry wants to look at the mole-to-mole ratio of different elements in a reaction, then I'm going to look at the moles of hydrogen and the moles of HCl. In order to do that, I'm going to convert 5 liters of hydrogen to moles of hydrogen. So I'll put liters H2 on the bottom, moles H2 on the top. And since this reaction is happening at STP, 1 mole of hydrogen, or really 1 mole of any gas, will have a volume of 22.4 liters. So that's the moles of hydrogen, but we want to relate it to the moles of HCl. So based on the balanced equation, there's an imaginary 1 there, 1 mole of hydrogen will react to produce 2 moles of HCl. And if I was looking for the moles of HCl, then I'd be done here, but since I'm looking for the liters of HCl, one more step. Now I'm going to have moles of HCl compared to liters of HCl. And since this reaction is happening at STP, 1 mole of HCl or any gas has a volume of 22.4 liters. So that's my mole-to-mole ratio, that's my stoichiometry. Now if you notice, when you're canceling things out, the liters of hydrogen cancel, the moles of hydrogen cancel, the moles of HCl cancel, you're left with liters of HCl. But also notice that the 22.4s will also cancel, because as long as this reaction is carried out at a constant temperature and pressure, the volume of any gas, whether it's hydrogen or chlorine or HCl, will all be the same. And since it's STP, both of those volumes are going to be 22.4 no matter what. So really, all you're left with is 5 times 2, which leaves me 10 liters of HCl. Let's try another one. All right, this time a sample of 52 grams of C2H2 requires how many liters of oxygen to react with it? At this time, we don't care about the carbon dioxide in the water because the question is not asking about the carbon dioxide in the water. So if it makes you feel more comfortable to X them out, then go ahead and X them out. So again, stoichiometry is about the moles of one product or reactant compared to the moles of another. So what we're going to need to do is look at the mole-to-mole ratio. Convert what you have to moles, then mole-to-mole ratio, then convert it back to what you need. Pause the video now, work this problem on your own. Alright, well I hope you did that. We got 52 grams of C2H2. The problem is those are grams, not moles. So we have grams of C2H2 to moles of C2H2. Since those are grams, not moles, my very first step is turning it into moles. 1 mole of C2H2 has a mass of 26 grams. And I got the 26 from 2 carbons weighs 24, 2 hydrogens weighs 2. That's a total of 26. So that's the moles of C2H2, but we need the moles of oxygen. So another step, moles of C2H2 compared to moles of oxygen. Based on the balanced equation, 2 C2H2s reacts with 5 O2s And that's the moles of oxygen, but we're actually looking for the liters of oxygen, so one more step. Moles of oxygen, liters oxygen. And since this is at STP conditions, 1 mole of any gas, and in this case oxygen gas, has a volume of 22.4 liters. So here we have 52 grams cancel out, times 1 over 26, moles cancels out, times 5 over 2, moles cancels out, times 22.4, and we end up with 112 liters oxygen. Let's work another problem. This time, how many grams of sodium oxide, that's this guy over here, will be produced when 46 grams of sodium, that's this one, react with 20 grams of oxygen under STP conditions? Okay, well, I have a mass of sodium and a mass of oxygen. So which one of those am I going to pick to find sodium oxide? And it turns out the best idea is to actually pick both. This is an excess limiting problem. One of those amounts is going to be in excess, one of those amounts is going to be limiting, but it depends on the mass of the individual element and their molar ratio with the product. So I'm going to do 2 separate problems. One of them with 46 grams sodium, and the other with 20 grams oxygen. So with the 46 grams sodium, that'll be grams to moles, moles to moles, and then moles back to grams. And Na2O weighs 62 grams. So the reason where the place where I got the 62 and the 23 came off the periodic table. I got the 2 and the 4 from the balanced equation. And the reason why I'm trying to find Na2O is because that's where my question mark is. And otherwise I'm just going to solve, and I end up with 62 grams Na2O. So let's do the exact same thing with oxygen. Actually, pause your video right now. You do the exact same thing with oxygen. Then pick it back up and see if we got the same answers. All right, well, hopefully you did that. We're going to go 32 grams of oxygen per mole. 1 mole of oxygen will produce 2 moles of Na2O. And 1 mole of Na2O has a mass of 62 grams. So 20, let me see if I can cancel out units here, grams of oxygen, moles of Na2O, and I end up with 77.5. Does that point better? Actually, let me erase that and do that whole thing better. 77.5 grams Na2O. So you might be noticing that we did not use 22.4 here, even though it said it's at STP conditions, because it doesn't ask anything about volume, so I didn't have to use 22.4. Even though I might be working with gases, I only need it if I'm looking for volume of gases, not mass of gases. And now I have 2 answers. One of them is 62 and the other one's 77.5. Well, 62 is much smaller than 77.5, which means that 62 is my actual amount that I will be able to produce. 62 is my actual amount that I'll be able to produce because that's the smaller amount. 46 grams of sodium will only produce 62 grams of Na2O, no matter how many grams the oxygen will make. The oxygen is in excess, so you exit out. All right, let's try another one, and this time we're going to make it a little bit tricky. If 10 liters of hydrogen at 800 torr, and that's supposed to be an R there, 25 degrees C are needed, how many grams of aluminum are required to react? So this case is going to be a little bit different because now we are not allowed to use that 22.4 liters. because it's no longer at STP. So you're going to have to do something different to try to figure out what those numbers are instead of just automatically using 22.4. I encourage you to pause the video right now and try this problem on your own, because there are multiple ways, multiple attempts, multiple different processes by how you can get this answer. So try it on your own and see if you can come up with an idea. All right, hopefully you did that. We are going to work this problem. Now here's my idea for how to go. I'm going to start with that 10 liters of hydrogen, and then 22.4 liters of hydrogen per mole, and then 3 moles of hydrogen per 2 moles aluminum, 1 mole aluminum for 27 grams aluminum. This is exactly like every single other problem that we've worked so far, and that's going to be my answer. The problem is it's not at STP. So 22.4 is a bogus number. It will not work because it's not at STP. So what we're going to have to do, or at least the way that I solve it, is to try to find what that number would be instead of 22.4. So I'm going to find the molar volume at 800 torr and 25 degrees C. V is equal to nRT over P. So since I want the molar volume, I'm going to use 1 mole of hydrogen. I want to know what the volume is going to be instead of 22.4 liters for a mole, 1 single mole. R is always the same number. Temperature 25 plus 273 is equal to 298 K. So 298 K. Pressure 800 torr. And there's 760 torr in 1 atmosphere, which is equal to 1.05 atmospheres. So working out this problem will tell me what the volume is of 1 mole at this temperature and pressure instead of standard temperature and pressure. I'm not going to write my answer down there. Instead, I'm going to put my answer directly in the problem, and I got 23.2 liters of hydrogen instead of 22.4, because the temperature is higher and the pressure is higher, the volume is going to end up being higher, so I got 23.2. Now that I have that, I'm going to work out my problem. 10 divided by 23.2 times 2 over 3 times 27. The units cancel. And I'm left with 7.74 grams of aluminum. If you worked this problem a totally different way, but you ended up getting something close to 7.7 grams of aluminum, then that's good enough for me. You probably have a different approach to this problem, and that's totally okay. Let's try one more. Again, you try your approach, and I'll try mine, and we'll see if we end up with the same answer. So pause now if you did the previous problem differently than I did. All right, if 54 grams of aluminum reacts with excess HCl at 0.75 atm and 10 degrees C, how many liters of hydrogen will be produced? So I want to know the liters at this temperature and this pressure, which is not standard temperature and pressure. So what I'm going to do is set up a typical stoichiometry problem and pretend like my stoichiometry is just normal, everything is fine, all is standard. 27 grams of aluminum is the mass of 1 mole of aluminum. 2 moles of aluminum will produce 3 moles of hydrogen, and 1 mole of hydrogen at standard temperature and pressure has a volume of 22.4 liters. But the problem is, it's not at standard temperature and pressure. So I'm going to take that 22.4 liters and make it disappear. And instead I'm going to do an entirely separate problem to try to find the molar volume at this temperature and pressure. The molar volume is the volume of 1 mole. R is always 0.0821 lacmole. Temperature is going to be 283 Kelvin, 10 plus 273, and pressure is 0.75 atmospheres. Now when I get this answer, I'm not actually going to write it down here. I'm going to write it down up there, because that will be the volume of 1 mole of any gas at 10 degrees and 0.75 atm. And it turns out that that 1 mole has a volume of 30.98 liters. So I'm going to use 30.98 instead of 22.4. And now I'll go back and work the stoichiometry problem. 54 divided by 27 times 3 over 2 times 30.98 gives me 92.9 liters hydrogen. So if you worked it a different way, but you ended up something close to 93 liters of hydrogen, then I'm sure that your way is just as good. And if you have any questions, you can definitely ask me in class. All right, well, that was gas law stoichiometry. We'll see you next time.